Here we go. We have a question, maximize the cut segment. We have given integer n denoting the length of a line segment, and we need to cut the line in such a way that the length of each segment is either x, y or z. X, y, z are integer and it is given. After performing the cut operation, our total number of cut segment must be maximum. So we have to return the maximum number of cut segments possible. Suppose n is 4. So our total length is 4 initially and the cut length are 2, 1 and 1. So for length n, n is 4, we make a cut at 2. So on the left hand side we have 2 length remaining and on the right hand side we have 2 length remaining. So for 2 length we can divide this into further 1 segment because x, y and z is 1. So we can cut and make the segment 1, 1, 1 and 1. So at the end our total answer is 4. So same goes for second test case. At first this question seems complex, but we will solve it easily. If you have solved this question coin change, uh, so the maximum cut segment is pretty similar to this. In this we have to find the fewest number of coins, and here I have to find the maximum number of cut segment. It is pretty similar to this. So let's build the approach. Suppose n is 11 and x is greater than n, it is also possible. Why I'm taking so much bigger value? X is equal to 17 because this many people have subscribed to this channel. So make sure you subscribe and click on the red button. Next we have y and z. So its initial values is 0 and we want to create the maximum segments. Initially there is only one segment 11, so the answer is 1, but we can divide this. Why I'm taking a dp? So this is a dp because in the description we have given that we have to find the maximum segment. So whenever there is a reference of maximum and minimum, so we have to apply dp here. So this we cannot use. Next variable we have y, so it is 5. Suppose, so we iterate from 5, we iterate from 5 onwards. Suppose there is only one segment of length 5, so the answer is 1. So we start from 5. For 5 length the answer is 1. For 6 length, for 6 length, this is 6, we cannot divide it like this. Why? Because we don't know whether we can divide the remaining. So the n is 6 or I is 6. If we make a cut at 5, the remaining length is 1. So for 1 you can see the answer is 0. So 1, the remaining length is not possible. So we cannot make a cut on 6. What about 7? The length is 7. If we make a cut on this, the remaining length is 2. So on 2, it is also not possible because the value here is 0. So the remaining length is not possible. So 7 not here. 6 is not possible, 7 is not possible, 8 is not possible, 9 is not possible. What about 10? Our length is 10. N or I is 10. So, and we have a value 5. This is 10. We have a value 5. If I make a cut here, the remaining length is 5. So, this is the remaining length. What are the maximum line segments on this 5? So, for 5, we have maximum line segment stored already. So, for 5, it is 1 and we have made a cut here also. So here answer is 2. Answer is 2. Because for the remaining 5 length, the answer is 1. It is uh, this cell stores the maximum value. The value is 1 and we make a cut here. So our total line segment, if we only include 5, then answer is 2. What about 11? We cannot make 11 because if we make a cut at here 5, 5, so the remaining length is 6. So for 6 we have 0 segments, so we cannot make this cut. So this is not possible. So you have to check. If I make a cut here with y, so it will left us with the remaining segment line. So you have to check whether the remaining or left out segment line is possible or not. In this case it is not possible, so we cannot make a cut here. So we have traversed with y, let's traverse with z. So for 2 we have 2 and z as 2. So this is the remaining string, and if z is equal to I, or this element, this is value, if value is equal to I, means here we can make a cut. So the maximum segment we have is 1. The answer is 1. Here the answer is 1. For 3 it is not possible. For 4, let's find out for 4. If we make a cut here, then the left out string is 2. So 2 stores the maximum value here is 2, and we make a cut. So 1 plus the remaining string, it is 2. So we store 2 here. Let's find out for 5. 5, if we make a cut, the remaining left out line segment is 3. What is the answer for 3? 3 is not possible, so we cannot make a cut here. What about 6? For 6, if you make a cut here, then the left out is 4. The answer of 4 is 2. So here it is 3. This is the crucial point. So pay 100% attention. If n is equal to 7 and we make a cut here, what is the left out string? The left out string is 5. So what is the value on 5? 5, the value is 1, and we make a cut here. So we have two portions. One is this and another one is this, the left out string, the left out line segment. So the value is 2. We we can break down 7 into 2 parts. What about 8? If I make a cut here, so it will lead me to the left out string. So for the left out string, the value is 3. So here it is 4. What about this? The value is 3. So this is also a crucial point. What about 10? 10, we make a cut here. The left out is 8. So what is the value here? 8. The value is 4, and we make a cut here. So the value is 5, and already stored value is 2. So we have to find the maximum between already stored value or the current value. The maximum value is 5. So we update our cell value with 5. What about 11? So for 11, let's find out the DP relation first. Never mind. So it is 11. If we make a cut here, so the left out string should be possible, or in this case it is 2. So the value must be equal to the current value. If the value is equal to I, means this is the given length and the value is itself the given length, so we cannot break, or the left out string is 0, so we can make a cut here. Means the line segment is 2 and we have to break down into two parts, so the maximum line segment or maximum portions we have is 1. So that's why it is important to write this. And the next condition is the left out string must be possible. Means the left out string I minus, this is the value, so I minus value. So dp, inside dp we have something and not 0, means the left out string must be possible. Then only we have to store here, we will store the already stored value dp of I, or the second thing we have is dp of I minus value, means left out string plus 1 plus 1. So in this case the n is 11, so if we break this we have one portion and the left out is 9. So what is the answer on 9? 9, it is possible to break, means the value is 3 here. So let's take out the value is 3, plus we have to add 1 because this is the one portion, and for the left out string or the remaining string the answer is 3. So here 3, so the maximum we have is 4, so we will store 4 and the answer is 4 in this case. 4 means if n is equal to 11, so we can break this 11 into 4 parts. So that's how we will solve this question. It is pretty similar to the coin change. So if you have not solved that question first, so I will link that question in the description box. Feel free to check out that question. Now let's jump into the coding part. We have a dp. Next, I stored this x, y and z values into a list. After storing the values into a list, we have to iterate by taking one value at a time, and we will start from this value onwards, the current value. If this is the only part, means I is equal to value, then we have a segment of 1, or the left out the remaining segment is valid, then we find the maximum between already filled value and the remaining value plus 1, and at the end we will return dp of n. That's how we will solve this question. If you have any doubt, feel free to ask in the comment section, and if you like this solution, just click on the subscribe button and also click on the like button. Thank you all for watching.